This is project 1.2, the Analog Oscillator or the A-stable multivibrator. This circuit can be powered three ways in its completed form. The first one is through the Schroeder power jack, which is already embedded in the case. The second way is through a power jack that's embedded and soldered on top of the PCB circuit. And the last way is using the wires coming out of a terminal block and plugging them into the battery directly. This circuit introduces timing. This timing is completed mainly by the capacitors seen in the middle of the circuit. The capacitors have a small tendency that causes them to have timing. This can best be visualized with the capacitor visualizer that I built in class. This exact circuit visually shows the property the capacitors have, where while they're charging, they induce a small current that is released through the negative side of the capacitor, as seen here, while the bicolor LED will turn red and it will slowly fade out. And once it's completely faded, as we know, the capacitor is virtually filled. As you can see here, it turns red, it's starting to fade out, and the capacitor is full. As we release it, the capacitor will release its current and go the other way, making the bicolor go a different color. Building and understanding the circuit came in three stages. The first stage is breadboarding and theory to figure out how the timing worked and to know how to use this in the real world. The second step was PCB to make the circuit more permanent and easier to understand and also easier to show. The final step was casing. This step allowed the circuit to be seen easier and powered easier through the Schroeder power jack that is built into the case. Another interesting thing to know about the circuit is that due to the oscillating nature of the circuit, the transistors, which are 3904 NPNs, if they were replaced with 3906 PNPs, the circuit would still work the exact same due to the fact that the LEDs would be on-off, and the inverse of that is off-on, which is the same results, and the current will act the exact same.